In this video I'm going to talk about strong hydrogen bonding. Strong hydrogen bonding is the attraction of hydrogen atoms covalently bonded to X to another lone pair of electrons on Y. X and Y represent nitrogen, oxygen, and fluorine. X bond H is a molecule or part of a molecule, and Y is part of another molecule. To have a hydrogen bond, hydrogen should be shared by two of these three elements, should be sandwiched between them. We have another definition here taken from Wikipedia, but this goes beyond the high school chemistry level. X here is not limited to three electronegative elements. There are more, but they form weak hydrogen bonding, and here I'm talking about strong hydrogen bonding. There are misconceptions among people regarding the hydrogen bonding. Some of them see the hydrogen bonding as synonymous with a covalent bond. So many people believe that hydrogen bonding occurs within single molecules rather than between molecules. Here I have a hydrogen atom, Bohr-Rutherford diagram for hydrogen atom, and Lewis structure. Lewis structure, by the way, is the representation of valence electrons in the outer energy level of electrons. So oxygen has two lone pairs of electrons and two electrons, 6 in the outer shell. Water forms two bonds with hydrogen, and there are two lone pairs of electrons. Now this pair of electrons between hydrogen and oxygen is not equally shared. This pair of electrons is more attracted toward the oxygen atoms, spend more time around the oxygen atom because we have a bigger nucleus here with 8 protons. As a result, the water molecule has a partial positive charge on this side, delta plus, and a partial negative charge on this side. The bond between hydrogen and oxygen is intramolecular force, and this is a polar covalent bond. If we bring another water molecule close by here, we'll see that this hydrogen, positively charged, is attracted to the lone pair of electrons. Electrons are negatively charged, so unlike charges, attract, and they form a hydrogen bond. So hydrogen bond is between molecules, not within, inside a molecule. Another misconception is that some people, anywhere they see hydrogen, they think a hydrogen bond can be formed. Let's take the methane and water. Methane, Lewis structure is represented here. There is a pair of electrons shared between carbon and each hydrogen, but this pair of electrons is almost equally shared. If you see the difference in electronegativity, you have 2.5 minus 2.2, hydrogen is 0.3. If the difference in electronegativity is smaller than 0.5, then we have a nonpolar covalent bond. If you bring another water molecule close to the methane, and you have a lone pair of electrons here, hydrogen here is not attracted to this lone pair of electrons because there is no positive charge on this hydrogen here. So no bond is formed between oxygen and hydrogen. Characteristics of hydrogen bonds. Hydrogen bonds should be attached, hydrogen should be attached directly to one of the most electronegative elements, to nitrogen, oxygen, and fluorine. Let's take a couple of examples here. Which of the following substances are capable of hydrogen bonding? Let's take the first one, methylamine, and draw the Lewis structure. We see the hydrogen is directly connected to the nitrogen. So this is capable of forming a hydrogen bonding. Let's take the second one, methanol, and we see hydrogen is directly connected to the oxygen. So it forms hydrogen bonding, is capable of forming hydrogen bond. Let's take the second one, third one, dimethyl ether. We have oxygen connected with 2 carbons and 2 lone pairs of electrons here. And we see hydrogen is not directly connected to oxygen. So this molecule does not form hydrogen bonding with other molecules like this. Another condition for hydrogen bonding is that electronegative elements should have a lone pair, must have a lone pair of electrons at least, which should be active. Nitrogen has 1 lone pair of electrons, oxygen has 2 lone pairs of electrons, and fluorine has 3, 1, 2, 3 lone pair of electrons. And they form hydrogen. They form hydrogen bonds with hydrogen. Examples of hydrogen bonds among substances themselves. So water molecule, ammonia and hydrogen fluoride. I have 4 water molecules here, and they are arranged in that way that this oxygen here forms 2 hydrogen bonds through lone pairs of electrons with another water molecule here, another water molecule here. And 2 more hydrogen bonds are formed through hydrogen positively charged at this point and hydrogen positively charged at this point. So 1 water molecule forms 4 hydrogen bonds, usually in ice. In water, the hydrogen bonds are formed, broken, reformed again, but in ice, the water molecules form 4 hydrogen bonds. Let's see the ammonia. Ammonia has 1 lone pair of electrons and 3 hydrogen atoms positively charged. It has the potential to form 4 hydrogen bonds, but because of shortage of the lone pairs of electrons, ammonia forms only 2 hydrogen bonds. Let's take this ammonia in the middle here. It forms 1 hydrogen bonding through this lone pair of electrons with this molecule, and another hydrogen bond through hydrogen positively charged here with this lone pair of electrons on another molecule here. Hydrogen fluoride forms covalent bonds and hydrogen bonds through the lone pairs of electrons and the hydrogen positively charged. Other examples are macromolecules. DNA, for example, has 2 hydrogen bonds between thymine and adenine, 3 hydrogen bonds between cytosine and guanine. These bonds, they keep the strands together. Here's another molecule of secondary structure of a protein. Hydrogen bonds are between these strands. And another one is a cellulose molecule, which has hydrogen bonds connecting the strands. Examples of substances that can form hydrogen bond with water. Water solubility for molecules such as glucose, table sugar, methanol, ethanol depends on the formation of hydrogen bonds between water and as a solvent and these substances as solute. Which of these compounds would be expected to form hydrogen bonds with water? I have 3 examples here. The first one is not capable to form hydrogen bonds with water. Why? Because hydrogen here is not directly connected to nitrogen, fluorine, or oxygen. And I explained we don't have a positive charge on the hydrogens here, so it's not forming hydrogen bonds with water. Second one, dimethyl ether. We have a oxygen here connected with 2 carbons, and there are 2 lone pairs of electrons. This lone pair of electrons here is attracting positively charged hydrogen on this water molecule here, forming a hydrogen bonds. The same way, the methanol has a hydrogen atom with 2 lone pairs of electrons, and this lone pair of electrons is attracting positively charged hydrogen on the other molecule of methanol. Thank you for watching the video.